Warning. First of all, I want to warn you that what I'm saying in this video might be incomplete or slightly incorrect because I am also a learner like you and still trying to understand and clarify these concepts as much as possible. So before we begin, I just want to say that you are watching this at your own risk. Please verify everything I say and don't take it blindly. Thanks. So let's start. So basically, uh, good evening everyone. So in this video, we will try to understand uh, the one of the most important concept of the networking, that what happen if we type an abcd.com or anything in the browser and how the things happen under the hood. Okay. So before starting the topic, we should understand what is the need of under, understanding this thing, because this is happening and why we need to study this thing or to understand this thing as a developer or as a software engineer, okay, or as a science guy. uh, so so the importance of this, so to understand the importance of this is very important. Okay. So the importance of this is that if we understand how the things are happening under the hood when we type anything on the browser and how we getting how the website is visible, then we can optimize the things more. Okay. Because we want, because as a website developer or as a software engineer, we want that our website load fast. Okay. So to optimize the speed and also to optimize the security of our website, we should understand this thing very deeply, okay, and very clearly. Then only we can optimize the things and we can make the things more fast and we can increase the loading of our website fast. Other benefit of understanding this is that the knowledge of this will help, may help in the troubleshooting. If there is some problem, if there is some networking problem in a website, then if we have the knowledge of this thing, then it will help. Okay. So I think these two are one of the most important uh, causes that motivate us to understand these things more clearly. Okay. And also, if we understand the things, then we can invent new things, we can make things more better. So that's why the understanding the things, understanding the whole picture of a system on which we are working is good. Now let's start. So now I will explain this thing in 2 to 3 parts. In first part, we will understand the DNS resolution. In second part, we understand other protocols that are being implemented uh, in this system, like UDP, HTTP, and how the TLS handshake works, and then and how the SSL certificates work. So in other 2 parts, we will discuss those things in more detail. So let's start with the DNS resolution. So I will start the things from very basic. Okay. So first of all, we will discuss the high level view of uh, this system. Okay. So 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 the system works like this. First of all, the user search anything in the browser. Like he can just type youtube.com, http slash www.youtube.com on the browser. After that, that request go to the server. Okay. Uh, and the browser send this request on behalf of us to the server. Then server process that request And after that, after processing the request and after authenticating and see that the things are valid or not, after the processing, the server send back the response. So the server send back the response to the browser, and then the browser render that response to the user. Okay. So now in this, let's say, so what I'm saying that the user can type youtube.com, okay, on the browser and then click the enter button. Now, now the the so in this story now the browser come. So what is browser? Browser is just like a software, okay, and its work is to render the response that it get from the server and to send the request to the server on the behalf of us, on the behalf of the user. Okay, so it is just a software that take the request from the user, send that request to the server, appropriate server, and then the response that it get back from the server, it just render it. Okay, so browser is just a software. Now, what is server? So server is just a machine like any computer machine or like any PC. So it is just like a normal machine that we are using. Okay. So we can, so basically the servers, so basically the YouTube servers are highly, so, so what I want to say is that we can call any computer machine a server. Okay. The server work is to serve, to distribute the web pages on the request of the users, okay, or on the request of the client. It distribute the web pages, okay. That's why it is called the server. The server is a machine to serve the web pages. Now we are saying that after getting the request from the browser, which is a client, the server process that request. In process, the things can be like it authenticate that the request, that whom it get the request is a valid person or not. Is is it not any hacker, or is it not someone who is restricted? So it process the request and it authenticate it. After that, it check that what the request is, what the request is, what web pages it is wanting. So every website have its own server, and like youtube.com has its own server. So basically the youtube.com uh, have configured the computer machines that can take the request from the client and send back the response and process those requests. Similarly, google.com has their own machines and they have configured those machines so that they can take the request, dot process those requests, and after that they basically send back the response. So so and then when the browser get the response from the server, it render that response. So what does the rendering mean? So it can be come in our mind. So rendering means is that the response that the response that the browser get from the server are the HTML files, or it can be JavaScript files, or anything like that. And so the browser cannot just display the code of those files. It just it process those files and then it show the UI. So when we type google.com on the browser send the request to the Google server, and then server send back the response. And in that response, the Google might have sent the HTML files or JS file or .js files or some images. We can see this thing in the inspect folder also. We can go here And if we reload, then we can see that the Google server have sent all these files, and these files are script, these files are documents, HTML files, text, it can be some image, okay, it can be like this. So the Google server has sent all these things, and then browser just parse this thing, it just process those things, and it display it like this, okay. So rendering means this. So now we have understand what is the high level view of this system. The user send, user type anything, it request, then browser take that request and send it to the right server, because there are many servers. Each website has its own server. So it check the request, that whom, and then decide to whom it has to send, to which machine, and then server process that request, and then browser get the response, and then it render it. So this is the high level view. Now what we are going to discuss in this series of the videos, part 1, part 2 and part 3, is that how browse how browser take the request from the user, and so basically how it make the request. We just type the youtube.com, okay, then how the browser make the request, and then how it decide to whom it has to send that request, to whom, to which machine it has to send that request, and then how this, all these things of sending the request to the server and then getting the request, so basically the getting the response back from the server, how all these things is happening, and how all these things happening is working securely, okay, implementing securely, okay. So we will understand this part of, so basically we will understand this part, we will understand this part, the browser to the server and then server to the browser, okay. And okay, so let's, so so in this process there are many steps. First of all, the DNS resolution happen, okay. So we will understand what I mean by DNS resolution, what is DNS, and all those things, and how this thing happen. After that, after DNS resolution, the TLS handshake happen, okay. And so in the next video I will explain what is TLS handshake. And after the TLS handshake, the SSL certificate and all the public key and private key exchangement happen. So I will explain those things, and I will also explain why all these things are happening, why these things are important, or why this, all these steps are needed. So what are the needs of this thing? And so in the letter two part, in part 2 and part 3, I will explain all these things. So let's start with the DNS resolution. Okay. So let's start with the DNS. Okay. What is DNS, or what is, so in this picture, first of all, the first character that is come is that is domain name. So what is domain name? Domain name is just a name. Like my name is Parth and your name is XYZ. So all the websites has a unique name. Like the google.com is the unique name for the Google website. Okay. Then youtube.com, facebook.com, instagram.com. Okay. So all these websites has, so every website has a unique name. So why a unique name? Okay. So we are requesting a data. Okay. And we are requesting it from a server, and each server has a unique name, okay. So so the unique name is must, because if there is not a unique name, then how we can say that I want a youtube.com if there are two servers of the same name? Then how the browser knows to which, so to which server it has to send the request? That's why So every server has a name. Now, this computer system, this internet mechanism, and all the devices like router, switches, browser, computer, and all these things don't understand these names. If so, basically, I cannot say that. Uh, so 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 the servers and machines do not understand these names like YouTube.com or Google.com. They they understand the IP addresses. IP addresses are like the it is just like a 32-bit number. Okay, like so the addresses are like 8.8.8.8. It is the IP address of some server. So it is just like this, and every server has a unique IP address. Okay, but remembering the IP addresses, some random unique number, is very difficult. If I just want to say, so basically, if domain names does not exist, then what will happen? And if we work with IP addresses, then what will happen? Then for each website, I have to remember a unique number like 8.8.8.8.8, or some like Google have. Let's take an example like Google have 110.236, something like a random six four digit like number, this like this. So basically a 32-bit number like this. So we cannot remember those numbers because there are so many websites and it is not practical to remember the numbers. Similarly, so this case is also implemented in the phone numbers. We just don't remember all the numbers. We just save those numbers by the name, okay? So that we do not need to remember the numbers. We just save it by name and then we can search the name and we dial to that phone number. Similarly, the things happen here, okay? So every server or every machine that is in the network or a big network like internet has a unique number, which and that number and that number identifies it, and that and we call that number the IP address. Okay, and that IP address, that number is mapped with a name because so that we does not need to remember the number, and we can just remember the easy names and we can just search those names and the request goes to the server. But in the internal mechanism of the internet, uh, we need the number. So there should be some mechanism where if we type youtube.com, that youtube.com converts into a number, and that and then the browser send the request to that IP address. Okay. So So due to this need, a DNS resolution come. Okay. So up to now we have understand the high level view of the system. After that we have understand what is domain name. We have understand what is IP address and what is the need of the IP address. What is the need of the domain name. Okay. And after that we have understand that what is DNS resolution. Okay. So we have understand what is the need of the DNS resolution. So basically the DNS resolution, the simple definition of it is that DNS resolution is just converting the name of the website into the IP address. Okay. So browser do this thing. The browser convert that name into the IP address of the server, and then when it gets the IP address, it send the request to that IP address. Okay, because the routers, switches, all those machines understand the IP address. It cannot send the request to the router and switches like that. I want the youtube.com. It have to give the IP address of that server, the corresponding IP address. It have to say that I want to connect to the 8.8.8.8. Not it can. It cannot say to the switches and routers, I want to connect to the youtube.com. Okay, that's why this DNS resolution, this conversion of the name into the IP address is needed. Okay, so this DNS resolution is a multi-step process. Okay? It is a multi-step process. So the things happen like this. We as a user say to the browser that we want the youtube.com. We just give the name. Then browser have to connect to the youtube.com server. But for connection, it needs the IP address of that server because it have to talk to the routers, switches, and other machines and other component of the network so that and f- and f- and it, so basically the browser have to talk to those things and and that and it so it can only talk to them by the IP addresses. Okay, so first of all, in this thing, so in this process, first of all, the first factor that come is the browser cache. The so the browser cache is come. So what is this? Okay, it is a very long process. Okay, and if you type the google.com, like let's say you type google.com and you visit this website in the morning. Okay, now in the afternoon you again visit this website due to some work. You again have to visit this google.com website. So in the morning the browser do all these steps, okay, and get the IP address of the google.com server. Now in the afternoon when you are again visiting the google.com, it if it again have to do these all these steps. So it is a very lengthy process, and every time a user visit a website, and we can see that we have to visit a particular website 5 to 10 times in a day. We have google.com, we have to visit this thing maybe 15 to 20 times a day. So the browser will do all these things, all these steps again and again, and it is a very lengthy process. Okay, you can see that is a very lengthy process. So in that case, the loading of the website will be slow. Okay, so to optimize the things and to improve the speed, what the browser do is that it store the IP address of a website in its cache. Cache is just a storage. It is a very small storage and it is optimized storage. By optimized storage, I mean is that the cache is a storage which browser can access very fast and it can retrieve the data very fast. Okay, so the browser maintains a cache of its own and it stores the IP address of the websites in that cache. Okay, so in the morning, let's say you visit the google.com and the browser do all these steps and by following all these steps, browser get the IP address. Then it store that IP address in its cache and it store that thing for a limited time, like say 1 day, 2 day, 1 week, 5 hours, 10 hours, like that. And it stored that IP address. So again, if I am I or you visit that website or a user visit that website again, then it does not have to follow all these steps again. It just she see the cache and it just see that it have the IP address of this website or not. And if it have, it just give the IP address directly. So it makes the loading fast. Okay. Now in this cache, there is a concept called ETL. ETL is time to live. Okay. So the thing is that so basically I can explain this concept later also, but we are talking about the browser cache. So let's do this thing here only. So browser stores the IP addresses of the websites regularly, okay, but it stores the IP addresses for a limited time, like one day, 5 hours, 10 hours, 12 hours, 24 hours, or a week, something like that, okay, according to the configuration. Why it don't, so why it just store for a limited time? Why it is not storing the IP addresses for the infinite time? This is because the Google is maintaining this website. It regularly improving its codes. Okay, it finding the bugs. So Google is not a dead website. The Google hires the engineers, and those engineers are working on it. And we have different websites, and there the developers are working on it continuously and improving the things and all those things. So it can be possible that maybe they are hosting that website in some server. Now they have changed that server and now they are hosting in some other server, and each server has a different IP. So it can be possible that it hosting in machine A, but now after doing some improvement or due to some reason, now they're hosting that website in a machine B, which has different website, so which have different IP address. So in that case, if browser caches the IP address of that website for an infinite time, then it always give the same IP. And if the server change, then the IP gets changed. In that case, the user will not able to access that website correctly because now the IP had changed. That's why the browsers save it for a limited time, like 7 weeks. So basically the 1 week or 2 week like this. Okay. Now we have understand the first part. The so the first so we have understand the first character in this process. Now it can also be possible that the browser cache does not have the IP address of that particular website. Okay, maybe the user is visiting it as the first time or the detailed time, so the IP address is expired. Okay, and the browser has just flushed that IP address from its cache. In those scenarios, what will happen is that the browser send the request to the operating system. Okay, and browser just call a system call. Okay, so now this is the concept of the operating system, is that the browser are the so the softwares we have. Okay, and below that software we have the operating system. In and in that operating system we have the operating system kernel. Okay, and whenever a software has to talk to the operating system kernel or operating system, you can say, it do this thing through the system call. It is a concept of the operating system. Okay, so now in this case, the browser do the system call to the operating system kernel, and it say to him that I need the IP address of this website, youtube.com. Please find the IP address of this website. I need this thing. Okay. So now, so now the request comes to the operating system, or we can say operating system kernel, which is a part of the operating system. Now it try to find the IP address of the of that domain name, the youtube.com. Okay. Now, what operating system kernel do that it does not know how to. So basically, it does not know how to find the IP address of a system. Okay, it is so this operating system is configured, and in its configuration, it is says that if any IP address or DNS query come to you, then you just go to the nsswitch.c config file. Okay, so this is a file somewhere stored in the etc folder. So basically, in Linux machines, there's a etc folder where all the configurations of the system is being stored. Okay, is stored. So, uh, so has been stored. So in that case, the request goes to the operating system, and operating system is configured that if any request, if any DNS query. So what I mean by DNS query? So the DNS query simply means is that the DNS resolution. So the DNS query is that if it means that finding the IP address of this DNS name. So if we say that finding the address of this so please find the IP address of this website youtube.com. So this whole thing we call it DNS query. So this operating system is configured that if any DNS query come to you, then you just go to the nsswitch.config file. So what this nsswitch config file is? This file is just a roadmap type thing. So basically, it is a configuration where we can also where it is configured that if any DNS query come to the operating system kernel, then how it resolve that query, how it find the IP address. So we have defined the Linux administrator or the programmers, or it is by default uh, it is configured, and in this file it is written that you have to go to this file, or you have to do this to find the IP address of the so basically to find the IP address of a domain name. So it is just like a roadmap. An operating system just follows that roadmap. So it is stored in the etc folder in the Linux system, and we can change this file. But if you have a good knowledge of the operating system and all the internal thing, then you can also change this thing. But it is very so the people say it is very risky, but but we can change this file. Okay, so the operating system sees that which file it have to see or look to get the IP address or and what to do. Okay, so in this file, it is configured that the operating system should first see this host file. It is also in the etc folder. So the operating system can follow the instructions that are written in this file, and it go to the etc host file. In this file, the things are very so basically the things are written like this, that IP address of this website is this, of this website is this, and of this website is this. So basically, a few websites, the I the IP so basically the IP addresses of few websites are listed here. An operating system can just see this file, and if it found the IP address of the of that domain, and if it see the IP address of that domain, it just search this file, and if it get the IP address, then it send back that IP address to the browser. But so the next step is this. Okay, it also can be possible that the operating system does not find the IP address of that domain. So basically, it also can be possible that that domain name is not listed here. So in that case, what it do is that it follow the DNS protocol. So we say that it follow the DNS protocol. So DNS protocol is just a list of some steps of some instructions An operating system do that. So basically, uh, what it does is that it go to the resolve.config file, and it is configured in the operating system code that if you don't find the IP address of a website in the host file, then you have to go to the resolve.config file. And this file is also in the etc folder of the system. Okay. So basically in this resolve.config file, what is there is that it contains the IP address of the DNS resolvers. So what is DNS resolver? DNS resolvers are the machines who take the DNS query and find the IP address of a website and send and then give the IP address to the client whom who is the person who is asking the IP address. Okay. So this resolve.config file contains the IP addresses of the websites. Okay. Because so the operating system just sees those IP address and it just requests. So DNS resolver are also the simple machines. Okay. Simple computer machines. But those computer machines are configured to find the IP address of a domain name, okay, of a website, of a server. So those machines are specially configured, and basically those are specially reserved for configured or implemented for finding the IP addresses of the servers. So this file contains the IP addresses of those DNS resolver machines. An operating system just connect to those machines and request and send a request that please find the IP address of this website. So, so basically this file contains two to three. So basically it can contain. So basically it contains 3 to 4 DNS resolvers IPs. So why they are 3 to 4? Because it can be possible that if it store only one the DNS resolver machine's IP, then it can be possible that that machine may be uh, so basically that is off or it is in some uh, so basically there is some maintenance type of thing or there is some error in that machine. That's why it is not able to take the DNS queries from the persons or from the clients. It cannot take those things. So so the operating system do so so basically there is a list of 3 to 4 DNS resolver machines. An operating system just send the request to the first DNS resolver. If it send back the response, then it is okay. It get the IP address. But if it gets some error as a response, then it send the request to the second DNS resolver machine. So it is work like this. Okay. So Google also owns a DNS resolver machine and it provide the so basically it solve the DNS queries by free. And that machine is hosted on 8.8.8.8 IP address. So basically it is this. So if I type this thing, then I just connected to the DNS.google. So basically it is the Google's DNS resolver machine, and we can get the IP address of any website like this. Like if I say youtube.com here, then I get the IP address of the youtube.com server like this. So so there are different companies who have this DNS resolver machines, and Google provide this service freely. Okay. So if you want the IP address of any machine, of any website, you can just go to this dns.google, or you can just type 8.8.8.8.8 like this, the IP address of the Google DNS resolver machine, and you can just request, and 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 you can just send the DNS query to this machine, and it will give the IP address of this machine. So operating system is also doing this. Operating system is connecting to the operating system is connecting to the DNS resolver machine, and it is just basically requesting and sending the DNS query and getting back the IP address. So so now the request goes to the DNS resolver. It is DNS resolver. Okay. So what DNS resolver do is that it also maintains the cache, because in the network there are so many machines, and those machines can be requesting the same uh, DNS query. Okay. So in that case, it just maintains the cache and stores the IP addresses of the websites for a particular limited time period, like 1 week, 1 hour, or 10 hours, 12 hours, like this, and it maintains that cache. So first, DNS resolver check the IP address of that particular domain name in its cache. If it found that it is good, it just send back the IP address to the operating system and then to the browser. But if it don't find the IP address in its cache, then what it do, it divide the particular IP address like youtube.com into three parts, into .com and youtube.com. Dot, we call the dot as the root domain. Okay. Then we call the com as the top level domain name. So the dot is called as the, so basically this is the nomenclature of a DNS name, of a domain name. So the dot is called the root level domain name. Com is called the right top level domain name. YouTube is called the left top level domain name, like this. So I'm not sure, but the so basically there is a nomenclature here. The dot is called the root, and com is called the top level domain name, and YouTube is called the secondary domain name, like that. Okay. So it divided, okay, like this. After that, this DNS resolver is a machine, and in that machine, there is some software running that doing all the things like that. So basically, in that machine, there is some software running where the developers has configured that first check the cache, then do this, then do this. In that case, do this and like this. So in that DNS resolver, the IP address of a root level domain server. So basically, name space server, the IP address of that is stored. Okay. So first of all, it connects. So basically, so the DNS resolver is a server, or we can say that it is a machine. After that, there are separate machines also, like a root domain name server. It is a separate server or a big machine somewhere, like a data center. Okay. Then we have a separate right top level domain name server somewhere in, so basically so they so basically there is a machine somewhere. Okay. Then we have a youtube.com name server. So basically this is also a separate machine which exists somewhere in the globe. So what the DNS resolver do is that it send the request to the root domain name server, and it say to him is that, so basically it say to him is that I've it just is say to it that, do you have the IP address of the youtube.com? Then root domain name server, which is a dot. So basically, uh, so bas so basically the DNS resolver connect to this name server, and this DNS resolver has the IP address of this machine, so somewhere stored in its code, and it is configured like that. If it does not find the IP address in its cache, then it have to connect to the this machine, this IP address, and send the request to this machine. And this machine is called the root domain name server, and it represents a dot. Okay, so basically it send the request to it, and it say to him that, do you have the IP address of the youtube.com? Then the root domain server authenticate and process the request, and it says that I don't have the IP address of youtube.com, but I have the IP address of com. So this com, okay. So basically there are different type of domain name like .com, like .io. Here you can see the .io, or in Indian websites there is .in. Okay, so each top level domain has their own separate name servers, and those separate name servers has a unique IP addresses, and those unique IP addresses are stored in the root domain name, and this root domain name server take the request, and it see that it is .com, so it sent the request. So basically it sent the IP address of the .com, this server. Okay, if it is .in, then it sent the IP address of the .in top level domain name server. Okay, like this. So when the DNS resolver gets the IP address of the top level domain name server, the right top level domain name server, then it sent the request to the right top level domain name server, and it request it that, and it asks that, do you have the IP address of youtube.com? Then the DNS resolve, then the top level domain name server says that I don't have the IP address of the youtube.com, but I have the IP address of a machine that, and that machine surely have the IP address of the youtube.com. So basically these youtube.com, google.coms have the, so basically these are the domain names, and these domain names are given by the domain registrar. Okay, and these domain registrar, so basically they are different type of uh, so there are different companies who gave these domain name, and they charge for it. So the youtube.com, so basically there are different companies like route 53 that owns by the AWS, the Amazon. Then we have GoDaddy, and so basically they are different companies, and these different companies basically gives the domain name, and they maintain, so basically they maintain a server, and those servers are taking the request from the DNS resolver. So basically those servers take the request from the, so those servers take the request from the clients, and basically they are companies. Okay, and they charge the money for this thing. Okay, so they charge the money in the way that they charge, so while giving the domain name, they, so basically they charge the money. Okay, and after charging the money, they just solve those DNS queries freely, because they are maintaining the machines, so they are spending some money, and any company spend the money if in the hope that they, so basically every company is doing the business. So they charge the money for the domain name. And after that, when we purchase the domain name, it just solve the DNS queries for those domain name. So the right top level domain name server, that is the .com name server, has the IP address of the youtube.com name server. Okay. And the DNS resolver then send a request to this name server and it asks that do you have the IP address of the youtube.com. Then the youtube.com name server says that I have the IP address and it sends back the IP address of the youtube.com. Okay. So there are two things. First is youtube.com server and the other is youtube.com name server. youtube.com server is a server that gives the youtube.com web pages, okay, the HTML files and all. And youtube.com name server is a server that maintains by the companies like AWS or like Azure or GoDaddy, like this. And these servers are maintained by them, and they just solve the DNS queries and gives like the IP addresses. Okay, this thing is not owned by the youtube.com. It is owned by the let's say the AWS, GoDaddy, or Azure, something like that. So we just say that youtube.com name server, but we should say that the AWS name server. So basically, we can say that the Route 53 name server or like this. And these servers contains the IP addresses of the different websites whose domain name they have give to the website owner. Okay. So this is how the DNS resolver gets the IP address of the youtube.com, and after getting it, it just send this thing. So when it get the IP address of this website, it's stored in its cache for a particular time period, and then it send that IP address to the operating system. Operating system then give that IP address to the browser. The browser save that IP address in its cache, and this is how the browser get the IP address of a particular website. So this is a very long process, and we are requesting so many services, those so many machines, and those machines are very far from each other. It can be like that, one machine in the north, other in the south, or something like that, and the user is in the east, something like that. So this is a very long process and it takes a long time. That's why we store the IP addresses and the response in the cache, so that every time we do not have to travel this whole process. So this is the first step of this thing. Okay. So you can see that we are just typing the youtube.com in the browser, and browser doing all these things in the backend. All these things are happening. And this is only the first step of this mechanism. So, so basically so the, so, so, so so the request that the browser sent to the server, it is the first step, the DNS resolution. And this DNS resolution itself is a very lengthy process. It is a very multi-step process. So basically we are connecting to the so many servers and all those things. So this is the thing. Okay. After DNS resolution, there are 3 to 4 more steps that happen. And after that, that request, and after all these 2 to 4 steps, the request go to the server, and then server send back the response to the browser. So you can imagine that this is a very big and complex process that is happening in just a single thing, sending the request to the server. Okay. And you also feel that, I think I hope you also feel that the importance of understanding these things. If we understand these things, then we can optimize the speeds, like we can change the TTL time of the cache, or we can secure the things like this. So as a developer, we should know all these things. So in the next video, we will discuss the further steps like TLS handshake, SSL certificate, and private and public key exchange, and all other protocols like HTTP, HTTPS, UDP, TCP, like this. Okay. So now the next part of this video is that the questions. The questions are very important because if we are not, if we don't have a questions, then it means that we are not processing the things. We are just mugging the things. We are just downloading the things, but we are not processing the things, and it is not good. Okay. So the first question that can come in our mind is that it is a very complex and lengthy process. Why the things are like this? It can also be possible that there is some big server, or we can say that a big machine, and it is storing the IP addresses of all the websites, and just and and just browsers send the request to that machine, and that machine have a very long list, billions of websites IP addresses, and it see in its data, and it's and then it just send back why there are so many machines. Okay. So this lengthy process has its own importance. The first importance is that there are there are billions of websites. Okay. The storage is not that much problem because it is just a key value pair, a single key value pair with the website and the IP address. Okay. So it take a lot of storage, but not that much. Okay. It is not that much. But the thing is that there are millions of people, and those people are requesting the so basically those all those people are sending the DNS queries. Okay. So there are billions of requests or trillions of requests. A single machine cannot handle all those requests at this scale. It cannot handle, and it cannot respond in milliseconds all those things. Okay. So one thing is that. Other thing is that all the websites are updating itself, so there can be possible that the IP address of a system get changed. In that case, we have to update regularly all those things. We also have to update these things here also, but a single machine, it is not possible. It is very difficult and complex, and we also have to maintain so many machines because we cannot put a single large machine in one corner of the earth, and all the people around the globe are sending that to single machine because some users are very far from that machine. So we have to maintain the so basically we have to maintain the replicas of all those machines, and updation is a problem in this case. Also, the security wise, it is also very important because if we store the IP addresses of all the websites in a single machine, then in that case, what happen is that if any hacker hack that machine, then all the websites get hacked or stopped. Okay. So it is very risky because a single machine can be hacked, but if there is a multiple machines, then hacking is very difficult. And if there are multiple companies, then hacking is possible, but all the websites are not hacked at a one time. Okay. So basically these threes are very important. Is that a single machine cannot handle the multiple requests at a time, the billions of requests or trillions of requests. It is a very difficult. Also, the security wise, it is very important that we just divide the things into the multiple machines, okay? So that if one thing is hacked, then other things are working. List, okay? So this is the thing. Then it 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 can also come in your mind that this is a very lengthy process. It is a good process, okay? But are there any researches going on to improve this system more? Okay, because everything has a because everything always has a space for the improvement. So, is there any research or is there any new setup is there in the market or not? So surely there is so basically surely there is some research is always going on this thing because DNS resolution is a very important thing. So surely it is happening, but implementing those new things is very difficult because all these things are set up already. But the things are there, and slowly, gradually, the new things comes in the market. Then slowly it implemented because we cannot just switch the things like this that one day we just change everything because so basically it is a complete structure and it cannot be changed in a single day. So there will be some research is going on. So we should research this thing. So basically we should search that as a part of the curiosity that is there any some research is going on or is not, is there any good system in the market or not, like this. And also the third question is that we should also try to find or invent some efficient system. So we should try to think or imagine that is there any system which is more better than this. So this is the end of the video of this. Okay, I hope you all understand this thing. I try to explain all these things as clear as possible. The video is lengthy and maybe I'm not explaining the things systematically, but I think with improvement, I just present my thoughts more systematically and but I try to explain each and every part. I explain the browser, cache. So basically, at a low level, so basically I just explain the things from the beginner level. I explain so basically I try to explain all these things at the beginner level from the start to the high level. Okay. So in the next video, we will discuss the other steps that happen in this. Thank you.